Okay, so it's 3:30. It's time for us to get started. So in our previous lecture, we started discussing some ways or algorithms or planning procedures for the location of departments within the facility. And as part of that discussion, we studied the systematic layout planning procedure. And also, which is mostly based on these qualitative aspects or measurements from the data that's available. And from there, we transition to the algorithm approaches that were using some quantitative method to quantify the order in which these departments are going to be placed within the facility. And among those, we study the first one listed here in red, the graph-based method. And the last thing we did on Monday was an example using the graph-based method. So in the assignment that you have, the new assignment, you will find problems in which you have to apply the graph-based method. Also the SLP method. And the last question in that assignment, you are not going to be able to solve that one until Monday, because on Monday we're going to cover the craft algorithm. Okay, so before we continue with the other algorithms, today I wanted to spend some time looking at some practical examples of applications of the systematic layout planning procedure. And today's lecture, we're going to show three examples. We're going to start with one that is more fictitious, and then we're going to move from that one, use that as an initial example, and from there we're going to move to a more realistic problems in facilities planning. So let me switch the presentation. So as I mentioned, today we're going to spend some time looking at three examples for the systematic layout planning procedure. And sorry for the ones that are watching. There you go. Actually, there are supposed to be three examples or case problems. The first one is I call it the Caveman Layout. This is a basic simple case, and we measure everything in feet. You see what that means in a second. And then the novelty luggage special. This is a manufacturing department, which the type of measurement that we are using is English. And then finally, we look at the luxury manufacturing LTD, which is a site planning application that uses the metric system. So for the Caveman Layout, in this problem, we have an overly simple case of making a layout by logical sequence for a caveman, say 25,000 years ago. So the space is nicely drawn here. And you can see the measurement that we are using is feet. We're referring to the size of the feet. And we are trying to allocate these 4 or 5 areas into this space. We have the fireplace, we have the sleep area, the property storage area, the entrance, and the work area. And we are going to follow the process that we discussed on Monday. We're going to use a rating description in which we have A with a value of 4, meaning that these two, if we are connecting or if we are assigning a value of A to two spaces, that means that those two spaces needs to be located close to each other. And then from there, we move down the list, especially important, then O or a single line, and then U, meaning that is unimportant, and X is undesirable. So you don't want them to close to each other. So we start the process from here. We know that we have this space, we have these 5 areas that needs to be located within this space. So from there, we can develop a this chart in which we are trying to decide the relationship between the areas, and we have a list of reasons why we are going to assign those relationships. So again, we're going to provide a rating. So for example, here, fireplace and the sleep area, we are assigning an O, meaning that it doesn't, it's not as high. Then we have sleep and property storage. So you want those to be close, right? With the important, the reason why is protection. And we also have, we have a relationship statement for each one of the combinations. So fireplace and property storage is unimportant. Fireplace and entrance is especially important. So we have a rating of 3 there, and so on. So as you can see, this is the first step. We have to look at the combinations of the spaces, and we want to give a rating in terms of the importance of these 2 areas to be located close to each other. We have additional information on this graph. We have information about the space. This is the area and the shape. So for example, here, 15 feet square, 3 by 5, 18 feet square, 3 by 6, 10 feet square, 2 by 5, and so on. So from here, we provide that rating between the combinations of the spaces, and we are also providing a reason why. So from 1 to 5, you provide a reason. This is designed by the decision maker. So you as a facilities planner will come up with this list. The rating is typical. That's not gonna change. But the reasons why you are giving that rating, those are decided by the facilities designer. Then from here, we are going to start developing our diagrams, the relationship diagrams. And we start with that relationship that was especially high, right? With an E. And that was for fireplace and entrance. So we want those to be close to each other. And from there, we start looking at the next relationships that are high. So we have all the E's already, it's just 1 E. Then we look at the I's. So we have 1 I here, another one here. Sorry. So we are adding those for 5 work area has an I between entrance and work area. So that's why we have 5 here with 4. And then we also have an I with 1. So that's why we are connecting those 2 with 2 lines. And then we have another I, which is separate from this group for sleep and property storage. So that's why we are connecting these 2. So now we move to the next one, which are the O's and the X. So for O's, we have only 1 between fireplace and sleep. So that's why we connect these 2. And then for the X, we have 2, we have one for sleep and entrance, and one from property and entrance. So that's why we have this line connecting those two. So what this means is we want to make everything possible for 3 and 4 to be located, not to be located close to each other. And same thing for 2 and 4. You don't want them close to each other. These two have to be, you have to make everything possible for them to be close to each other, 1 and 4. And then 5, you have some flexibility with 5 and 2. So now we have this. The final diagram after changing, it's the same diagram. Now we are accommodating the nodes. This is the final diagram. And we are adding the amount of space as part of the information on those nodes. So the sleep area is 18 feet square. The property storage is 10 feet square, and so on. So using this diagram plus the area, we can attempt to locate the departments into this space, which is what we were given from the beginning. So using, again, this information, we know the shape, we know the area. Now we have an idea of how the departments should be accommodated. In this area, we can use the squares to allocate the area. And this is one way that we can achieve this organization that was depicted in this diagram. So you see 3, you want 3 to be far from 4. So that is accomplished. 4 is right here, 4 is the entrance. So 3 is way back here. And 2 is also here in the middle. It's located far from 2. 1 and 4 are located next to each other. And 4 and 5 as well. And 5 and 1, they're all located close to each other. 1 needs to be close to 2. So that's happening right here. And the only thing that we are seeing that are close to each other, and it's not necessary, but end up being that way, it's 2 and 5. Okay, but you don't have a limitation like this one for 2 and 5, so that's fine. 2 and 5 can be close to each other. And then again, this is gonna be the solution. So we end up with the location of the departments based on the requirements for the problem. Questions? Okay, because again, this is the initial example. We're now gonna move to more practical. So this is the final drawing. So we have the bed, the work area, fire, the entrance, and the storage. Okay, so now let's talk about the novelty luggage special. This is a company that produces to order an infinite number of end products. Each item is ordered special. However, all items involve printing on thin plastic sheet material. End products are tennis racket covers, beach bags, windbreakers, jackets. Most of the product have printed on them special logos, crests, commercial messages, graphics, or small thought statements. Printing on the material, while it is still flat, is the key service provided. Sport clubs and high school are typical end users. The overall layout of the plant is shown on this sketch. So we have the plant. Here we have the dock. Here at the top, we have the different departments. So in this problem, we are not going to be redesigning the facility. What we are going to be designing is the department itself. the location of the items inside the department, specifically for this one right here, the sales screen. So the sales screen department in the lower right is continually jammed. Although there are only 3 workers involved, there is excessive congestion and plant spoils. The 3 workers have convinced the plant manager that if they could open an exit door to the area immediately west of the department, the flow of material will be improved and the congestion reduced. That is a convincing argument, and the plant manager has said, okay. Before opening a new door and just changing things around, he was asked the 3 employees to show him a plan of proposed layout for their area with the new door opening in the west wall. So what they're proposing is to avoid the jam here, to open a door in this side, the left wall of the sales screen, to change the flow. So the problem is, assume that you are the team leader for this detailed layout planning project. Follow the simplified SLP methodology to make at least one layout for the area. Assume that the exiting door on the east-west aisle way will stay, and a new door will be opened at the west end of your area. Okay, so this area is currently walled off from the rest of the plant, even though doors are open most of the working hours, in order to reduce dust and properly ventilate the area. So here's some information about what we are going to be placing in this area. So we have the activity area number and description. So you have the entrance from cutting. This is the existing doorway. We have an exit to assembly, which is a proposed doorway. We have the incoming hall, which is an area like this, which has 6 2x3 carts. The finish hall has 3 2x3 carts. The auto paint press has an area of 4x6. The hand paint press has an area of 3.5x4. And the dryer is what you're seeing right here. It uses up this much area, 44 feet by 4. We have the screen storage, 9x2. Paint storage, which is wall-off area already fixed in the building. I have the cleaning tank and table, 5x2 and 4x2. We have the screen preparation, 6x4, and we have the Littman's desk and time clock, which is a 4x3 station. Okay, so we have that information. These are the things that are going to go inside the department. And then we want to know what are the relationships between these activities areas. Let me use the right name. So the activity areas. So what are the relationships between them? Which ones needs to be close to each other? Again, this information that I'm giving you right now, because I'm unable to take you to the facility to collect this data. So I'm giving you this information, but remember, in practice, you will have to go and find out, okay, these 2 machines or these 2 areas needs to be close to each other for this reason. These 2 needs to be separate because of this reason, and so on. And you will use that information to create this diagram. So as we did for the previous example, we have a reason, a code. So flow material, rush or urgent condition, supervision and control, labor efficiency, fire hazard. And we are using this notation to denote the importance of the relationship between departments. So absolutely necessary, especially important, important, ordinary, unimportant, and undesirable. So for all the 13 activity areas, we have a relationship. You can see that there's a lot of use. So those are unimportant, meaning that doesn't matter if they're close to each other or not. But for this group right here, we can see that there's a especially important, absolutely necessary, and so on. So we need to find those. We're gonna have to start with the A's, then move through the list to the E's, to the I's, until we get to the undesirable. This will take you a lot of time, but once you have this, then you can move forward with your design. Okay, so let's take one example. So entrance and the incoming hold, especially important for the A's, the auto print press and the load and dryer, absolutely important. So those two needs to be closed. And then we have the X, the load and dryer and the paint storage, they need to be, they can't be close to each other. The reason why, 5, it's a fire hazard. So you don't want them too close to each other. Actually, for most of the X, you see the 5. So that seems to be the major reason for keeping them apart. And so on. So from here, what's next? Start drawing the relationship diagrams. We have more information here for the 13 activity areas. We have the name, we have the machine or equipment identification number. We have the space in terms of left, right, front, back, the height, the area of the machinery, the operators and work maintenance area. So all these things are important. So at the end, what you want to have is the total net area that is needed for each area. So for example, the incoming hold, you need 36 square feet. For this auto paint press, you need 88. But you only get to this number until taking into account all the pieces that are needed in that area. What else? Physical features required. This is relevant. You see here 110 AC and then 220 AC. So you need to take into account if you need to plug in this equipment, if you have an area to plug in the equipment, right? So for this auto paint press, you need to make sure that you are close to a 110 plug. For this one, you need the auto dryer, you need both, and so on. And then in terms of what else is needed, compressed air. So do you have a connection close to this one, and so on. So all this, very important for you to make those decisions. What else? So going back to the area, again, we are proposing to open this new door here, the door on the left. And the assignment is, now that you are going to have that new door, how are you going to accommodate all these areas inside the department? So we have the space, we have the relationship diagrams, we have the information about the area, so we can move on. So, sorry, should be, that's the title for the previous example. But the activity relationship diagram, we start with the A's and the E's. If you go back to here, we're finding all the A's and the E's, and we are connecting those. So this is the initial diagram with all the 4 lines and 3 lines. So you have 2 groups here, 2 graphs, they're separate. And then we have the I's. We have 5 I's. So this is the next one. And you see that this group still independent. And then we have a new group here, 9 and 12. Diagram 3 recognize that 7 and 8 are one piece of equipment and rearrange for best fit of A's, E's, and I's. And we also have the O's and the X. So you see 8 and 10, they need to be far apart. Same thing with 7 and 10. And then the rest become kind of a little bit messy here, but we recognize that these two are one piece, so they have to stay close. Now the question is, how do we arrange this so we can locate the materials or the activities inside the space? So after playing a little bit with the graph, we have the diagram number 4, in which 1 and 2, 2 here and 1 here, are oriented to the doorways by flipping over and using the mirror image of the diagram. So we still keep this. This is the same piece of equipment, 7 and 8. We have 2 close to the new doorway. We have 1 close to the old doorway. And we are also trying to keep 10 away from 7 and 8 for the fire hazard. Okay, so the question now is, using this, can we fit everything in here? So now we are putting the areas into the diagram. See all those areas that I showed you at the beginning? This is the diagram with all those areas now instead of the nodes. So by rearranging those spaces, seems like we can fit the areas inside the space that was given while keeping this guy right here as far as possible from this machine. For the rest of the diagram, you see the 4 lines here. So you are making sure that these two are close to each other. Also, these two are not far. That the lines that seems to be far away are those that are a single line, but those that are 2 and 3, you see that they are close to each other, especially this one, which is four lines, and these two that have 4 lines as well. So there's no unique solution for this type of problems. What you're trying to do is to come up with a design that can fit the area and is trying to meet those requirements that you are assigning with the specifications as best as possible. You want to make sure that this type of relationship are always met, the X, and also the absolutely important ones, you want to make sure that those are satisfied. With the rest of them, you have more room to move things around. So this is the final design for the area. Yeah, and this is the design with the new doorway. Questions? Okay, so this final example is on a manufacturing facility that we have to design from scratch. So in this one, it's different from the previous one. The previous one, we were looking at a department. We want to arrange the machines or the areas inside the department. In this one, we have the entire facility, and we have a set of departments that we want to locate inside the facility. So this is the manufacturing space or the area. And this is luxury manufacturing that develop, produces, and distribute toiletry, and personal care products. The company is located in Bangkok, Thailand, and is a subsidiary of an international firm. The company has enjoyed sustained growth, and its top management foresees the need for additional facilities. After thorough investigation, a new site was selected in Saripuri province, 85 kilometers from Bangkok. The site is shown below. So this is the site. A couple of things that are important here: the size. Each square represents 100 meters square. We have access roads around. So we have a highway here. We have another highway on the right. And in this one, we have no trucks, no access for trucks. So that's the main difference between these two areas. So the top management wants a master site plan so that the available space can be effectively utilized for the long run. That is, the initial need for building is only about 1/4 of the amount of the site's available land. Company has room for doubling its under roof space and has open land for roads, parking, water retention, and utilities. It wants a site plan now, good for this future expansion. The initial space needs call for separation of production facilities from warehouse and supporting services. Also, the laboratories must be segregated in their own building. Note the restrictions for commercial vehicles on the west side of the property. North and east highways are not limited for commercial vehicles. The site slopes gradually to the southeast. The problem is you have been assigned to develop a master site plan for this new site when it will grow to full site occupancy. Question: how to proceed? So let's see where we start. Here we have a list of the areas that we need to accommodate in this space. So we have the North Highway access, the East Highway access, West Highway access. Those are given, as we show here in diagram, North, the West, and the East. Okay, so we have different access. We have the lab space, we have the office space, the production space, warehouse space, service space, the utilities corridor, and then we need some space for stormwater retention. Okay, so we need to accommodate that on the site. And then we are gonna keep using our rating here of A, E, I, O, U, and X. So again, I'm giving you this information, but in practice, you will have to go and gather the data that you will need in order to come up with this rating. So based on the information collected, we have some requirements here. So for highways, obviously you don't need these three, they're separate. So U would be unimportant. It's very important for the labs to have a North Highway access. Okay, so that's important in this case. The reason given a rating of 3, then we have some especially important, the lab and the offices, they need to be close to each other. Do we have any A's? Yes, production and warehouse. Looks like that's very important, so we want them together. E, production and service is also important, so we want them close to each other. Do we have any X here? I don't see any X. So at least we don't have to worry about the not desirable locations. Mostly have A's, E's, and I's, and then the rest are U's. We have the O here, ordinarily close this, okay. So with this information, we proceed as we did for the two, yes. Reason why you have the, oh, these numbers? That's a good question. So since it is unimportant, you don't necessarily have to provide a reason why. Oh, this side? Yes, so that's why, because we don't have any other department to connect to. So typically you will have nothing here. Yeah. This will, the size of the triangle will increase as you add more spaces in the diagram. Good question. So from here we have additional information about the spaces, the departments of the areas. So we have a total area of 15,000 meters. And then we have the area needed for each of these departments. We have additional information here, water drains, steam, compressed air, as we saw from the previous example. So all this data is relevant in terms of knowing where to place these spaces. We have the maximum floor loading, light, heavy, and light. Yeah, so from here, what's more important is the space that is needed for each one of the departments. So we start the process. Diagram 1 is showing all the A's, E's, and I's. So that's coming from here. And then diagram number 2 is redrawing diagram 1, but adding the 5 O's, which are the ones. From here, we move to the final diagram, which includes activity area number 2 must be on the east side. So that's what we are forcing here. So thus reverse flip this diagram horizontally. And we are also including the data in terms of the area for each one of the departments. So as you can see now, we have the organization. We have the location in terms of what will be the location for each one of the departments inside the facility. So the question now is, do we have enough space to meet this organization or this graph? So looking at the space that we were given and now substituting the nodes by the area, you can see that 3, 6, 7, and 2 are still together. We have 8 and 9 here, and 10 going in this direction. And we keep 4 and 5 at the top with the highway 1 close to it. We were making sure that 7 is close to this 8 East highway. So that relationship is very important. These two are together. So that relationship is very important. These two are together, especially important. And what else? These two are close to each other, very important. And then the rest of the relationships are 2s, like this one, this ones, and this ones are 1s. So it looks like we're able to set up the departments following our diagram without any issues. And this will be the final layout with that information without the arcs and the notes. You see everything fits nicely. We have parking space, car bike space here, parking, and the retention area, truck parking, and so on. And that's the final slide for this presentation. Okay, so do you have any questions about this material? So you'll see that in the assignment, you have some problems related to this material. The reason I wanted to spend time with these examples today is this is one of the most practical tools that you will end up using from this class. I encourage you to go over this and see, I mean, it's not very difficult. Again, the challenge from these methodologies to gather the information that you need to make these decisions. Once you have that information, the process is straightforward. And yeah, so if there's no questions, then I'm going to stop here today. And then on Monday, we are going to continue the discussion. Keep in mind that a week from Monday, we're going to have our first exam. So on Monday, we're going to cover the last material for the first exam. On Wednesday, we will have our review. And then on Monday, September the 27th, we will have our first exam. You have an assignment, make sure that you work on that. If you have questions, let me know via email and we will talk. Okay, good. I'll see you on Monday.